The ground beneath your boots is solid rock, reddish-brown in color, and covered with a layer of fine dust that shifts slightly as you step forward. You have traveled farther than any human has traveled before, and now you stand on the surface of another world, a planet that orbits a star called Proxima Centauri. The horizon on this world curves in every direction, lower and sharper than Earth's horizon, and the landscape stretches toward distant formations that might be hills or ancient crater rims. The sky above holds a sun, but not the sun you knew on Earth. This world circles the nearest star to our solar system, a red dwarf that sits just over 4 light-years from home. The journey that brought you here took decades, though you experienced less time due to the effects of traveling at speeds approaching light. The star hangs in the sky now, larger than the sun appeared from Earth, and its light carries a warmer, redder tone that changes the appearance of everything it touches. Proxima Centauri b was discovered in the early 21st century, identified through the tiny gravitational wobble it caused in its parent star as it completed each orbit. You are listening to the Drowsy Astronaut, and we are taking a slow journey together through possible futures where humans live on worlds beyond our solar system. This is an experience, a deep exploration of what these places might look like and what daily life could be like for the people who eventually call them home. Where on this beautiful planet are you listening from tonight? And what time is it right now? Let us know in the comments below. If this journey feels like something you would like to continue, a like or subscription helps us keep exploring new worlds together. Now, let us return to the surface of this world, where the dust is ancient and the rock has never known a single drop of rain. The star provides warmth, though not as much as Earth's sun would deliver from this distance. You stand roughly 5 million kilometers from Proxima Centauri, far closer than Earth orbits the sun, yet the red dwarf produces only a fraction of the solar energy. The calculation balances out, and the surface temperature here hovers near levels that allow liquid water to exist, at least in theory. The air pressure is unknown, as is the exact composition of any atmosphere that might wrap around this world. But the models suggest possibilities that include breathable conditions with the right protective equipment. Looking down, you notice the texture of the ground changes, where your boot displaced the surface layer. Beneath the dust lies darker rock, perhaps volcanic in origin, though no volcano has been active here for timescales that Earth-based geology struggles to describe. The dust itself is fine, almost powder-like, and it settles slowly back into place once disturbed. There is no wind at this moment, no breeze to carry particles across the surface or to erase the marks your boots leave behind. Each footprint remains sharp and clear, a record that could persist for millions of years if the conditions stay stable. The gravity feels lighter than Earth's pull, though not dramatically so. Proxima Centauri b holds roughly the same mass as Earth, perhaps slightly more, and its radius falls within a similar range. The result is a surface gravity close to what your body knows from a lifetime of Earth-based experience. Walking feels natural, though each step carries you slightly farther than it would at home, and jumping would lift you a bit higher before the planet pulled you back down. The difference is subtle, noticeable but not disorienting, a gentle reminder that this world formed from different materials under different circumstances. Behind you, the lander sits on its extended legs, silent and still, now that the engines have cooled. The structure rises several meters above the surface, and its shadow stretches across the ground in a direction determined by the star's current position. The metal exterior reflects some of the red-tinted light, and the equipment visible through the open access panels shows no sign of damage from the landing. Supply containers rest nearby, arranged in careful rows, and the beginnings of a habitat dome can be seen partially assembled at the edge of the landing site. This equipment represents years of planning, construction, and the hopes of people who will never see this place themselves. Turning slowly, you scan the full circle of the horizon, taking in the landscape that extends beyond your immediate position. To the east, if that term holds any meaning here, the ground rises gradually toward what might be an elevated plateau. To the west, the terrain appears flatter, with scattered rocks breaking up the otherwise smooth expanse of dust-covered regolith. The north shows darker patches that could indicate different rock types, or perhaps areas where subsurface materials have been exposed by ancient impacts. The south holds a depression, shallow but wide, that might be a degraded crater worn down by processes that operated over geological time. The star itself demands attention whenever you glance upward. Proxima Centauri appears roughly 3 times larger in the sky than the Sun appeared from Earth, a noticeable difference that changes the character of daylight here. The color registers as deep orange-red, warm in tone but cooler in temperature than the yellow-white light Earth's sun produces. The edges of the stellar disk are crisp and clear, and looking directly at it for a moment does not bring the immediate pain that staring at the sun from Earth would cause. The red dwarf burns at a lower surface temperature, around 3,000 degrees compared to the sun's 5,000 plus degrees, and its spectrum peaks in wavelengths that human eyes perceive as red. This lower temperature explains why the habitable zone around Proxima Centauri sits so close to the star. Earth orbits the Sun at nearly 150 million kilometers, a distance that places it in the zone where water can remain liquid on a planetary surface. Proxima Centauri produces far less energy, and its habitable zone huddles much closer, within just a few million kilometers of the stellar surface. The planet you stand on completes one orbit every 11 Earth days, circling its star in the time it takes Earth's moon to go through less than half of its phases. The year here is short, rapid, and the seasons, if any exist, would cycle with corresponding speed. The light quality affects everything you see, shifting colors away from their familiar Earth-based appearance. Your suit is white, or was white when constructed on Earth, but here it takes on a pale pink tone under the illumination from Proxima Centauri. The rocks appear redder than they might under different light, and the dust looks almost rust-colored in the areas where the starlight strikes directly. Shadows are deep and dark, with less scattered light to fill them, and the contrast between illuminated and shadowed areas is sharper than you remember from Earth. The sky itself, if there is atmosphere enough to scatter light, might show colors that no human language has developed words to describe precisely. Time passes differently here, not in the relativistic sense you experience during the journey, but in the practical sense of days and years. The planet likely exhibits tidal locking, a gravitational interaction that causes one face to permanently point toward the star, while the other remains in eternal darkness. If this is the case, and the models suggest it is probable, then the concept of a day becomes meaningless in the traditional sense. The star does not rise or set from any fixed location on the surface, but instead hangs at a constant position in the sky, moving only slightly due to orbital dynamics and the planet's slight axial wobble. You might be standing in the twilight zone, the band of space between the scorching day side and the frozen night side, where temperatures allow for moderate conditions. The dust beneath your feet is ancient, beyond the capacity of human intuition to grasp easily. This world formed roughly the same time as Earth, over 4.5 billion years ago, when the galaxy was younger and the universe was smaller. The particles that make up this surface have been here through all of that time, accumulating slowly from impacts, volcanic activity, and the gradual breakdown of surface rock. No plate tectonics have recycled this material into a planetary interior and brought it back transformed. No erosion from water or wind has carried it across continents and deposited it in new locations. The dust simply exists, layer upon layer, undisturbed except by the occasional meteorite impact or distant tremor. Walking forward several steps, you approach a rock that protrudes from the surface, larger than the others nearby. The stone stands roughly waist-high, and its surface shows a texture that suggests it cooled from molten material at some point in the distant past. Small pits cover the exposed face, evidence of micrometeorite impacts that have sandblasted the rock over millions of years. You reach out and touch the surface, and the stone feels cool through your glove, though not as cold as you might expect. The star provides steady heat, and materials that absorb that energy have had time to reach equilibrium with the incoming radiation. The silence is complete and profound, assuming the atmosphere is thin enough or absent enough to prevent sound transmission. If air exists here, it might carry sound, but there are no sounds to carry beyond the ones you create yourself. No wind howls across the plains, no water trickles through channels, no insects hum in the background. The planet produces no noise, offers no audio environment beyond what you and your equipment generate. The experience is not peaceful in the way a quiet forest on Earth might be peaceful, where subtle sounds of life continue beneath the apparent stillness. This is the silence of a world that has never spoken, that has no voice and requires none. Your helmet display shows readouts from the exterior sensors, confirming that conditions match the predictions within acceptable margins. The radiation levels are higher than Earth's surface, as expected from a red dwarf that produces frequent stellar flares. The magnetic field strength is lower than Earth's protective magnetosphere, or perhaps absent entirely, leaving the surface more exposed to charged particles from the star. The atmospheric pressure reading is low, though not zero, suggesting a thin envelope of gas that might include some of the molecules necessary for human life. Water vapor traces appear in the spectroscopic analysis, a promising sign that this world holds reservoirs of water somewhere, perhaps locked in polar ice or hidden in subsurface aquifers. The distance from Earth feels real and present in a way it did not during the journey, when the ship was its own world and the destination was still theoretical. Now the separation is concrete, measured in light years, that translate to communication delays of over 4 years each way. A message sent to Earth from this location will travel outward at light speed, crossing the empty space between stars, and will arrive 4 years and 3 months after you transmit it. The reply, if it comes, will take another 4 years and 3 months to return. Any conversation with home is a conversation across nearly a decade, and real-time communication is impossible. The isolation is absolute in ways that no human has experienced before, deeper than the isolation of polar explorers or astronauts on the moon. The journey to the next world takes you farther from the Sun than Proxima Centauri, though the method of travel remains theoretical in the present day and certain in the future you are exploring. The destination is a planet called TRAPPIST-1e, and it orbits a star even smaller and cooler than Proxima Centauri. The distance from Earth measures roughly 40 light-years, a gulf that requires technologies and time commitments that make the Proxima journey seem brief by comparison. The star system itself is remarkable, holding not one potentially habitable world, but 7 planets packed into orbits that would all fit within the distance from the Sun to Mercury. TRAPPIST-1e occupies the 4th position in this compact arrangement. As your craft descends through the atmosphere, the first thing that becomes visible through the viewport is water. The surface below shows no continents, no islands, no exposed rock breaking through the endless expanse of liquid that wraps around the entire planet. The ocean reflects light from the star, and the color registers as a deep blue-green, darker than Earth's tropical waters, but lighter than the deep ocean trenches you might remember from images or experience. Waves pattern the surface, visible from altitude as textured variations in the reflected light. Clouds drift above certain regions, white and thick, generated by evaporation and the circulation patterns that move moisture through the atmosphere. The landing is not a landing in the traditional sense, as there is no dry ground to set down upon. Instead, the craft settles onto the surface of the water itself, and flotation systems deploy to keep the structure stable and upright. The transition from flight to floating is smooth, and the gentle motion of waves beneath the craft becomes immediately noticeable. The rocking is subtle, rhythmic, and constant, a reminder that this world's surface is dynamic in ways that the rocky planet you left behind was not. The water extends in every direction, meeting the sky at a horizon that appears farther away than it would on a smaller planet, but closer than Earth's ocean horizons due to this world's size. Stepping out onto the deployment platform attached to the side of the craft, you are immediately aware of the moisture in the air. The atmosphere here is thicker than the thin envelope around Proxima Centauri b, and humidity saturates every breath you take through the suit's filtration system. The air temperature reads as moderate, warm enough to prevent ice formation, but cool enough to support the liquid water that defines this environment. The star, TRAPPIST-1, hangs in the sky as a small reddish disk, even dimmer than Proxima Centauri, and the daylight here carries an even deeper red tone that makes the water appear almost burgundy in certain lighting angles. The water itself is the primary feature, the overwhelming reality that shapes everything about existence on this world. Looking down from the platform, you can see the surface moving with the waves, rising and falling in patterns generated by wind and possibly by tidal forces from the other planets in this closely packed system. The transparency of the water allows you to see down a few meters, though the depth beyond that fades into darkness. Marine snow, particles of organic material or mineral grains suspended in the water column, drift slowly downward, visible in the shaft of light that penetrates from above. The ocean depth is unknown at this location, but planetary models suggest it could reach 100 kilometers or more in some regions. A water layer so deep, it begins to form exotic high-pressure ice phases near the interface with the rocky core far below. The platform includes a ladder that extends down into the water, and you decide to descend several rungs to bring yourself closer to the surface. The water laps at the lowest rungs, and you can see the liquid clearly now, moving with a motion that seems both familiar and alien. The chemistry is likely not identical to Earth's oceans, though the presence of liquid water implies certain constraints on temperature, pressure, and composition. Salt content is unknown, and the question of whether life exists in these depths remains unanswered despite all the observations and models. You reach down carefully and let your gloved hand break the surface, and the water parts around your fingers, ripples spreading outward in circles that interact with the existing wave patterns. The sound of water is constant, a soft lapping against the sides of the craft and the support platform, a gentle slosh and splash that creates an audio environment completely different from the silence of the rocky world. The waves are not large, perhaps half a meter from trough to crest. At their largest, and they arrive in irregular intervals that suggest complex generating forces. Wind moves across the water, and you can feel the pressure of moving air even through your suit. The wind is steady, rather than gusting, blowing from a direction that might correspond to the planet's circulation patterns, driven by uneven heating between the day side and night side if this world is tidally locked, like its neighbor Proxima b. The sky above shows clouds in various stages of formation and dissipation, and their shapes are unfamiliar, stretched and layered in ways that reflect different atmospheric dynamics than Earth's weather systems. The clouds are thick enough to cast shadows on the water below, and you can see the patches of darker water where cloud cover blocks the star's light. The temperature difference between illuminated and shaded areas is noticeable, and the water in the sunny patches feels slightly warmer when you lower a sensor package into it. The thermal energy from the star penetrates the upper layers of the ocean, creating a warm surface zone that might extend dozens of meters down before temperatures begin to drop with depth. Behind the floating craft, a larger structure is visible, anchored to the water's surface with deep-reaching tethers that extend down beyond visibility. This habitat dome is constructed to float permanently, designed to rise and fall with the waves while remaining stable enough for human occupation. The transparent sections of the dome reveal interior spaces where equipment and living quarters have been established, and small boats are tied to docking points around its perimeter. This is the beginning of human presence on an ocean world, a settlement that has no bedrock foundation, but instead floats on water that is kilometers deep. The concept of building on solid ground does not apply here, and every structure must account for the constant motion of the surface and the forces exerted by waves, wind, and currents. You climb back up to the main platform and stand watching the waves move past, and the patterns begin to reveal themselves through observation. The waves approach from a consistent direction, suggesting a prevailing wind system that blows across thousands of kilometers of open water without any landmass to interrupt its flow. The fetch, the distance over which wind can act on water, is essentially unlimited on a planet with no continents, and this allows wave systems to develop characteristics that might differ from anything Earth's oceans produce. Swells from distant storm systems could travel across entire hemispheres before reaching this location, carrying energy generated in conditions you cannot directly observe. The horizon is empty of any feature except the line where water meets sky, and the uniformity is both beautiful and unsettling. On Earth, even in the middle of the ocean, you know that land exists somewhere beyond the visible horizon, that sailing or swimming in any direction will eventually bring you to a shore. Here, no such certainty exists, and traveling in any direction would only bring you to more water, extending endlessly until you circumnavigated the planet and returned to your starting point. The psychological impact of truly endless ocean is difficult to predict, and the first inhabitants of this world will need to adapt to the absence of solid ground in ways that go beyond the physical challenges. The water temperature variation with depth creates layering in the ocean, and these layers might host different chemical environments, different pressure regimes, and potentially different forms of life if biology emerged here independently. The warm surface layer, heated by the star, could support photosynthetic organisms if the right chemicals are present, and if the light spectrum from TRAPPIST-1 provides usable energy despite its red-shifted nature. Below that, a thermocline zone where temperature drops rapidly might create a boundary that separates surface processes from deep processes. And far below, in the cold, high-pressure darkness, exotic conditions might exist that have no parallel in human experience or Earth-based oceanography. The concept of a storm on a planet-wide ocean is worth considering, and the models suggest that weather systems here could grow to sizes that dwarf Earth's largest hurricanes. Without land to disrupt circulation patterns or to absorb energy, a rotating storm system could persist for months or years, drawing energy continuously from the warm surface water and organizing itself into structures hundreds or thousands of kilometers across. The early warning systems for such storms would need to function across vast distances, and the floating habitats would need to either move away from approaching systems or secure themselves to withstand conditions that might include waves dozens of meters high and winds that reach speeds no structure could safely endure above the surface. Despite these challenges, the water itself represents a resource that the rocky planets lack in such abundance. Liquid water is the foundation for the kind of chemistry that life requires, at least the kind of life that Earth has produced. And the presence of an ocean this large means that the planet holds hydrogen and oxygen in quantities that could support human needs for effectively unlimited time. Electrolysis could separate water into breathable oxygen and hydrogen fuel. Desalination could provide fresh water if the ocean is salty. And aquaculture might eventually provide food if Earth-based organisms can adapt, or if native life proves compatible with human biology. The ocean is both the challenge and the answer to the question of sustainability on this world. You descend the ladder again, this time going lower, until the water reaches the level of your boots. The liquid is clear, and you can see your reflection on the surface, distorted by the gentle motion of the waves. The reflection shows your suit, your helmet, and the red-tinted sky behind you, all rendered in the wavering mirror of the water. The moment feels significant in a way that is hard to articulate. This first contact between human presence and an alien ocean that has moved and flowed for billions of years without witness. The water accepts your presence without reaction, continuing its eternal motion, indifferent to the significance that you assign to this encounter. The day here, if the planet is tidally locked as expected, does not end with sunset, but continues indefinitely with the star fixed in the sky. The location of this floating settlement might be in the permanent day zone, where the star never moves far from its position overhead, or in the twilight band, where the star hangs near the horizon, or even in the night zone, where creative solutions would be needed to harvest energy. The choice of location represents a fundamental decision about how humans will adapt to this world, whether to embrace the constant light, to seek the moderation of twilight, or to challenge the darkness with artificial systems. Each option brings different constraints and different possibilities for the shape of life on an ocean world. The transition to the next world brings you to a planet larger than Earth, a super-Earth with roughly twice the mass and a diameter that exceeds Earth's by about 50%. The gravitational pull is stronger here, and you feel the difference immediately as the landing craft settles onto the surface. Standing requires more effort, and moving demands conscious adjustment to the fact that you weigh significantly more than you did on Earth or on the previous worlds you visited. The planet, designated Kepler 442b, orbits a star somewhat cooler than the Sun, and the orbital period places it within the habitable zone where temperatures allow liquid water to exist. The most immediate and overwhelming characteristic of this world is the atmosphere, and it presses down on everything with a weight that goes beyond the increased gravity. The atmospheric pressure at the surface measures roughly 3 times Earth's sea level pressure, and the air itself has substance and presence that you can feel, even through your suit. The thick atmosphere creates effects that are visible in every direction, and the sky above shows depth and color that result from the scattering of light through far more air molecules than Earth's atmosphere contains. The color is a rich, deep blue, more saturated than any sky you saw from Earth, and it gradients smoothly from darker blue overhead to paler blue near the horizon. Looking at the horizon, you notice that visibility is limited compared to the sharp, clear horizons on the thinner atmosphered worlds. The air itself carries a slight haze, not from pollution or particulates, but simply from the density of the atmosphere and the way light scatters through it. Objects in the distance become less distinct, fading into the blue haze in a way that reminds you of looking across long distances on Earth, but more pronounced and present at shorter ranges. A mountain range visible in the distance appears blue-tinted and softened, its sharp edges blurred by the atmospheric effect that painters on Earth would call aerial perspective. The air temperature is moderate, cooler than you might expect given the thickness of the atmosphere, and the dense gas envelope regulates temperature effectively across the surface. Heat from the star is distributed through atmospheric circulation, and the sheer mass of the air means that temperature changes happen slowly and moderately. Day-to-night temperature swings are minimal, and seasonal variations, if the planet has an axial tilt sufficient to create seasons, would be gradual and gentle. The greenhouse effect from all this atmosphere keeps the planet warmer than it would be with a thinner air layer, but the calculations suggest the system remains within habitable ranges due to the star's characteristics and the planet's orbital distance. Sound travels differently through this thick air, and the acoustic environment is noticeably altered from what you are accustomed to. Sounds carry farther and with different tonal qualities, and the denser medium transmits vibrations more effectively than Earth's thinner atmosphere. When you speak, your voice sounds different even through the suit's communication system, which tries to normalize the audio but cannot completely compensate for the changed medium. Equipment sounds, the hum of the craft's cooling systems, and the mechanical noises of the habitat modules all take on characteristics that mark this place as fundamentally different from the lower pressure environments you have experienced. The weight of the atmosphere is not just a measurement, but a physical sensation that affects everything you do. Breathing requires slightly more effort to move air in and out of your lungs, even with the suit's assistance, because the pressure gradient between your respiratory system and the outside environment is different. The suit itself is designed to handle this, maintaining an internal pressure that keeps you comfortable while managing the interface with the external environment. Moving through the air feels subtly different, as if the medium itself has more resistance, though the difference is small enough that you adapt to it quickly through unconscious adjustments to your movements. The thick atmosphere provides substantial protection against radiation from space, and the layers of gas above you serve as effective shielding that reduces exposure to cosmic rays and charged particles that would be more dangerous on worlds with thinner air. This protection is one of the significant advantages of super-Earths with dense atmospheres, and it means that surface habitats can be constructed with less radiation shielding, simplifying construction and reducing the mass of materials that needed to be brought from Earth or produced locally. The air itself is the shield, kilometers thick, and composed of molecules that absorb or scatter harmful radiation before it reaches the surface. Looking upward through the depth of atmosphere, the star appears slightly dimmed compared to how it would look from outside the air layer. And the scattering of light creates a glow in the sky that extends beyond the star's actual disk. The scattering is more pronounced in the blue wavelengths, which is why the sky appears so deeply blue. And the red light from the star penetrates more directly to the surface. The effect is similar to Earth's blue sky, but intensified by the greater atmospheric depth. And sunset here would display colors that result from light passing through even more air as it approaches the horizon at a low angle. The landscape extends in all directions, and the terrain shows features that result from geological processes operating under higher gravity and denser atmosphere. The mountains in the distance are lower and broader than the steep peaks Earth's geology produces, because the increased gravity makes it harder for rock to support extreme elevations without collapsing under its own weight. Slopes are gentler and valleys are wider, and the overall impression is of a landscape that has been compressed and softened by the stronger gravitational field. Erosion proceeds differently here, and the dense atmosphere means that wind can move larger particles more easily, shaping the surface through processes that have no exact Earth equivalent. Weather patterns develop in the thick atmosphere, and the movement of air masses creates systems that are both similar to and different from Earth's weather. Clouds form at various altitudes, and the depth of the atmosphere allows for multiple cloud layers that would rarely occur on thinner atmosphered worlds. The lower gravity of cloud formation means that water vapor condenses at different altitudes, and the resulting cloud structures are stratified and complex. A storm system visible in the distance shows a tall cloud structure that rises higher than the base of the lower atmosphere, and the system moves slowly across the landscape, driven by temperature differences and the planet's rotation. The density of the air affects how rain falls, and the increased atmospheric drag on water droplets means that rain falls more slowly here than on Earth. The drops themselves might be larger, having more time to coalesce as they descend through the thick air, and the impact when they reach the surface is gentler than you might expect from drops of that size. This creates a rainfall experience that is unique to high-pressure worlds, where precipitation arrives as large, slow drops that fall almost lazily through air that resists their descent. The psychological effect of such rain is calming, and the sound it makes against surfaces is deeper and more rhythmic than the sharp patter of earth rain. The vegetation, visible near the habitat modules, shows adaptations to the local conditions. Though whether these plants are Earth-derived species, modified for this environment, or native life forms is not immediately clear. The leaves are broad and thick, designed to capture light efficiently in the diffuse illumination that results from atmospheric scattering. The structures are low to the ground, reflecting the challenges of growing tall in higher gravity, and the overall impression is of a plant community that is robust and well anchored, but not reaching for the sky the way Earth forests do. The green color appears shifted slightly toward blue-green under the light, filtering through this atmosphere, and the photosynthetic processes might be adjusted to work with the altered spectrum. Moving forward from the landing area, you notice that each step feels heavier, and walking requires a deliberate effort to lift your feet against the combined pull of gravity and the weight of your own body under that gravity. The suit adds its own mass, and the total load you are carrying is significantly higher than it would be on Earth. Fatigue sets in more quickly, and the energy expenditure of simply moving around is noticeably greater. Long-term residence on this world would require physical adaptation, muscle strengthening, and cardiovascular conditioning to handle the constant increased load, and children born here would develop with bodies shaped by this higher gravity from their first moments of life. The horizon, despite the atmospheric haze, shows hints of water in the distance, and the models suggest that this super-Earth likely has significant surface water in the form of oceans or large lakes. The water would be held firmly in its basins by the strong gravity, and the ocean depths could be greater than Earth's deepest trenches without the pressure becoming sufficient to form exotic ice phases, because the surface gravity is high enough to compress the water significantly under its own weight. The interface between the thick atmosphere and the surface water would create weather systems that draw energy from evaporation and condensation, driving circulation patterns that distribute heat and moisture across the planet's surface. The settlement here is more permanent than the floating structures on the ocean world, with buildings constructed from local materials and anchored deeply into the bedrock below. The architecture is low and spreading, with wide bases and minimal vertical extent, designed to minimize structural stress under the higher gravity. The interiors are comfortable, with pressure equalization systems that manage the transition between the external pressure and the lower pressure maintained inside for human comfort. The entry airlocks are more robust than those on lower pressure worlds, and the process of entering and exiting the habitat requires careful attention to pressure management to avoid injuries from rapid decompression or compression. The time you spend outside is limited by the physical demands of moving in higher gravity under thick atmosphere, and you return to the craft to rest and prepare for the next phase of the journey. The experience of this world lingers, the feeling of weight and substance, and the deep blue sky that speaks of air piled kilometers deep above you. The thick atmosphere is both a protective blanket and a heavy presence, and learning to live here would mean accepting that the air itself is a tangible part of the environment, not just the invisible medium it seems to be on thinner atmosphered worlds. The next destination waits, and it will present different challenges and different wonders shaped by the particular characteristics of its star and its formation history. The journey continues to a world that orbits a red dwarf star, one of the most common stellar types in the galaxy, and the most likely host for planets where humans might settle. This particular planet circles its star at a distance of only a few million kilometers, far closer than Mercury orbits the Sun. Yet the star itself is so much cooler and dimmer that this proximity places the planet squarely within the habitable zone. The star is designated GJ 1214, and the planet that bears its name with an added letter has been known about since the early 21st century, through transit observations that caught the planet passing in front of its star as seen from Earth. Descending toward the surface, the first thing that strikes you is the quality of light, and the color of everything below is transformed by the deep red-orange illumination from the star. The star itself is visible through the viewport, and it appears dramatically larger than the Sun looked from Earth, roughly 10 times the diameter due to the close orbital distance, despite the star's smaller actual size. The disk glows a deep orange red, and looking at it directly is possible without the pain that the sun's brightness would cause, though the intensity is still sufficient to be uncomfortable for extended viewing without eye protection. The surface below shows a landscape bathed in this perpetual sunset light, and the colors are shifted away from their Earth-normal appearance into reds, oranges, and deep browns. What might be green vegetation appears almost black in the red light, because chlorophyll reflects green light and absorbs red, and under a red sun, the plants take on dark, almost charcoal tones that make the landscape feel alien in a fundamental way. Water, if present, appears deep red-brown, reflecting the sky and the light from the star overhead. The rocks and soil show colors that might be similar to their appearance under white light, or might be completely different, and distinguishing the material's actual color from the color imposed by the lighting is difficult without spectroscopic analysis. The landing is gentle, and the craft settles onto solid ground that appears stable and dry. Stepping out onto the surface, you are immediately aware of the warmth, despite the dimness of the light. The star produces less total energy than the Sun, but the close orbital distance means that the energy per square meter reaching this surface is comparable to what Earth receives. The warmth is real and present, and the surface temperature is moderate, falling within the range where humans can operate comfortably with appropriate equipment. The air temperature is regulated by the atmosphere, which on this world is substantial enough to distribute heat and maintain moderate conditions across the day side of the planet. The star hangs in the sky at a position that suggests this location is within the region where tidal locking has fixed the planet's rotation to match its orbital period. The star does not move in the sky except for slight variations due to orbital eccentricity and libration effects, and the concept of a day in the traditional sense does not apply here. Time is measured by the orbital period, roughly 38 Earth hours, but from this location on the surface, the star remains essentially stationary. The red light is constant, unchanging, and the landscape exists in a state of perpetual late afternoon or early evening, depending on how you choose to interpret the color and quality of the illumination. Looking toward the horizon, you see hills and valleys rendered in deep reds and browns, with shadows that are surprisingly dark given the relative dimness of the star. The shadows are sharp where the red light strikes at direct angles, and the contrast between illuminated and shadowed areas is pronounced. The star's lower temperature means that less blue and green light is present in the spectrum, and the scattering in the atmosphere preferentially affects what little blue light exists, possibly giving the sky a tint that is hard to describe accurately, somewhere between deep amber and brownish red, depending on the atmospheric composition and the angle of observation. The vegetation, if that is what the dark patches scattered across the landscape represent, would need to function with the photons available from this red dwarf star. Red light carries less energy per photon than blue light, and photosynthetic processes would need to capture more photons to generate the same amount of chemical energy. The plants here, whether native or adapted Earth species, would likely have pigments that absorb red and infrared wavelengths efficiently, and their appearance would be dark almost to blackness under the red illumination. In white light, these same plants might appear blue, purple, or even silver if they reflect the wavelengths that the star does not provide and absorb the ones it does. The star's proximity creates a significant presence in the sky, and the gravitational interaction between the planet and the star is strong enough to generate tidal effects that extend beyond just the rotational locking. The planet's interior might experience tidal heating from the flexing caused by gravitational gradients, and this internal heat could contribute to geological activity that maintains volcanism and plate tectonics despite the planet's age. The surface shows signs of relatively recent geological activity, with smooth lava plains visible in some areas and what might be volcanic cones rising from the landscape in the distance. The day side of this planet experiences constant illumination, and the ecosystems here, if any evolved naturally, would be adapted to endless day. Plants would not experience diurnal cycles, and any animal life would not have the day-night behavioral patterns that Earth organisms exhibit. The concept of sleep might not exist in the biology of this world, or it might take completely different forms driven by other environmental cycles. The settlers here would need to maintain artificial day-night cycles within their habitats to preserve human circadian rhythms, because the external environment provides no natural cue for when to rest and when to be active. The temperature gradient across the planet is extreme, with the day side receiving continuous heating, while the night side, permanently turned away from the star, experiences temperatures that might drop to levels where the atmosphere itself begins to freeze out onto the surface. The twilight zone between these extremes is the region where moderate temperatures exist, and the models suggest that this band, stretching around the planet like a ring of habitability, would be the primary location for settlement. The position where you stand might be at the edge of this zone, where the star hangs near the horizon, and the conditions are as favorable as this planet offers. Wind is a constant presence, and the air moves from the day side toward the night side in powerful circulation patterns, driven by the temperature difference. The winds you feel are steady rather than gusting, blowing from the direction of the subsolar point, the location on the planet where the star stands directly overhead, and the surface receives maximum heating. The moving air carries heat and moisture, if moisture exists, from the hot side toward the cold side, and the return flow at higher altitudes completes the circulation cell. This circulation is simple compared to Earth's complex weather patterns, but the energy involved is substantial, and the wind speeds in some regions might reach levels that would be categorized as hurricane force on Earth. The habitat modules here are designed with the constant wind in mind, and the structures are streamlined and low to the ground to minimize wind resistance. The settlement is positioned in a location where the local terrain provides some shelter from the prevailing winds, and additional wind barriers have been constructed from local materials to create a more protected environment. Solar panels, or rather stellar light panels, are positioned to capture the red-orange light from the star, and they are designed with different semiconductors than Earth-based panels to match the spectrum of this red dwarf sun. The efficiency is lower than equivalent panels on Earth because the lower energy photons provide less electrical potential, but the constant illumination compensates for the reduced efficiency. The psychological impact of the red light is something that the first settlers here are still assessing, and the reports suggest that humans adapt to it more easily than expected. The brain's color perception is relative, and after some time under this illumination, the reds and oranges begin to seem normal, and the mind compensates for the shifted spectrum. Bringing in white light from artificial sources provides contrast and helps maintain the connection to the spectral environment of human evolution. But the exterior environment, the world itself, is red and orange and deep brown, and that becomes the visual reality for those who spend extended time on the surface. The star's lower mass and temperature mean that it will burn for trillions of years, far longer than the sun's expected 10 billion year lifespan. This planet will remain in the habitable zone for timescales that dwarf the current age of the universe, and the potential for long-term habitability is essentially unlimited by stellar evolution. The red dwarf will continue shining, essentially unchanged, long after the sun has exhausted its fuel and expanded into a red giant that consumes Earth. In that sense, this world offers a stability and longevity that no planet around a sun-like star can match. And the settlers here live under a sun that will outlast their species by timeframes that are difficult to conceptualize. The radiation environment is more challenging than around calmer stars, and red dwarfs are known for producing stellar flares, sudden releases of energy that can increase the star's brightness temporarily and flood nearby planets with high-energy particles and radiation. The planet's magnetic field, if it possesses one, provides some protection, and the atmosphere absorbs much of the radiation. But surface dwellers need to be prepared to take shelter during flare events. Early warning systems monitor the star's activity, and alerts provide enough time to move to shielded areas before the worst of the radiation arrives. The flares are a regular feature of life here, and the frequency varies, but averages several significant events per Earth year. Standing on this world, under the large red sun, you feel the warmth on your suit and see the landscape transformed into tones that no Earth environment naturally produces. The experience is both familiar and deeply strange. A planet that meets many of the conditions for habitability, but does so in a way that constantly reminds you this is not Earth. The red light is the most obvious difference, but the tidal locking, the constant winds, and the stellar flares all combine to create an environment that demands adaptation and acceptance, that human life can exist in forms and under conditions that Earth never prepared us for. The journey continues, and the next world waits with its own set of challenges and characteristics. The next destination is a world where the most immediate and inescapable reality is weight, and you feel the difference the moment the landing craft settles and you prepare to stand. This planet is a super-Earth with significant mass, roughly twice what Earth contains, and the surface gravity is correspondingly higher, approximately 1.6 times Earth's gravitational acceleration. Before you even step outside, the suit systems alert you to the increased load, and the servos in the joints activate to assist your movements against the stronger pull. Standing up from the seat requires noticeably more effort, and the sensation is similar to carrying a heavy backpack on Earth, except that the weight is distributed across your entire body uniformly. Stepping down onto the surface is an act that requires deliberate control, and the landing is heavier than you intend, the stronger gravity pulling you down faster than your Earth-trained muscles expect. The ground beneath your boots is solid rock, similar in appearance to the surfaces of other rocky worlds, but the interaction between your body and the ground is fundamentally altered by the gravitational field. Every movement requires more energy, and the simple act of walking forward is a conscious effort rather than the automatic process it becomes on lower gravity worlds. Your muscles engage more strongly, and you can feel the increased load in your legs, back, and core as they work to support and move your body mass under this enhanced pull. The planet orbits a star somewhat larger and brighter than the Sun, and the surface temperature is maintained within habitable ranges by a combination of orbital distance and atmospheric composition. The atmosphere here is thick, similar to the super-Earth you visited earlier, and the pressure at the surface adds to the overall sensation of being pressed down by forces from above and below. The air itself has weight, and the column of atmosphere above you contains more mass than the equivalent column on Earth, contributing to the feeling that everything here is heavier and more substantial. Looking around the landing area, you see that the terrain is relatively flat, and the settlement has been deliberately placed in a region where slopes are minimal to reduce the energy cost of moving across inclines. Walking uphill in this gravity would be exhausting, and even gentle slopes would present significant challenges for anyone spending extended time on the surface. The habitat structures are low and wide, built close to the ground with minimal vertical extent, and the architecture reflects the reality that lifting materials against this gravity is expensive in terms of both energy and structural engineering. The buildings spread outward rather than upward, and the overall impression is of a settlement that has been compressed by the gravitational field into a horizontal arrangement. Walking slowly forward, you notice that your stride length is shorter and your gait is more careful and deliberate. The extra weight makes balancing slightly more challenging, and the consequences of falling would be more severe here than on Earth, with impacts carrying more force and injuries potentially more serious. The suit's assistance systems help compensate, providing support and stability, but the overall experience is one of constant awareness of the gravitational pull. Jumping is almost out of the question, requiring more leg strength than you can comfortably muster, and the few centimeters you might manage to lift yourself off the ground are hardly worth the effort involved. The fatigue sets in quickly, and within just a few minutes of walking and exploring the area around the landing site, you can feel the increased cardiovascular demand and the muscle fatigue from supporting extra weight. Your heart rate is elevated, working harder to pump blood through your body against the stronger gravitational gradient. And your breathing is deeper and faster as your body demands more oxygen to fuel the increased metabolic activity. This is exercise at a level that would be moderate on Earth, simply from walking around on level ground, and the long-term health implications for settlers here include both benefits and challenges. The benefits might include increased bone density, stronger muscles, and improved cardiovascular fitness for those who adapt successfully to the higher gravity. The skeletal system would respond to the increased load by building denser bones, and the muscular system would develop the strength needed to function in this environment. Children born here would grow with bodies adapted from birth to the stronger gravitational field, and their physical capabilities in this gravity might eventually exceed those of Earth-born adults who arrived as immigrants. The challenges include the risk of injury, the increased energy requirements for all physical activities, and the potential for cardiovascular stress in individuals whose bodies cannot adapt successfully. The habitat interior is maintained at standard pressure, and gravity cannot be reduced, but the interior spaces are designed to minimize the need for vertical movement. Ramps are gentle, stairs are rare, and living areas are arranged to keep everything within easy reach without requiring bending, lifting, or stretching against the extra weight. Furniture is robust and low, designed to support the increased weight of human occupants. And the overall design philosophy prioritizes accessibility and energy conservation. The psychological impact of living under constant heavy gravity is something that researchers are still studying, and the reports from early settlers suggest that adaptation is possible, but requires time and deliberate effort. Outside the habitat, you see evidence of construction techniques adapted to the high-gravity environment. Materials are strong and dense, chosen for their ability to support loads without deformation or failure. Foundations are deep and wide, anchoring structures firmly to the bedrock below to prevent settling or collapse. Cranes and lifting equipment are more robust than their Earth equivalents, designed to handle the increased weight of materials and components. The entire construction process is slower and more energy-intensive, and the settlement grows at a rate constrained by the physical demands of building in this gravitational field. The vegetation growing in the agricultural areas near the habitat shows the effects of the stronger gravity in its structure. The plants are low and spreading, with thick stems and wide bases that provide stable support against the pull. The leaves are smaller and thicker than their Earth counterparts, and the overall growth pattern is horizontal rather than vertical. Trees, if they are present, are short and broad, more like bushes than the tall structures Earth forests produce. The gravitational field shapes the biological adaptations here just as it shapes the human experience. And any life that evolves or is introduced on this world must account for the constant, inescapable pull. Children born on this world are a subject of particular interest, and the few that have been born so far are growing under observation to understand how human development proceeds in higher gravity. The infants appear to develop stronger neck and core muscles earlier than Earth babies, a necessary adaptation to support the increased weight of their own heads and bodies. Their motor development follows a different timeline, with some milestones reached later and others earlier, reflecting the challenges and demands of the gravitational environment. The long-term effects will not be fully understood for decades, as these children grow into adults and potentially have children of their own, creating a second generation of high-gravity natives. The psychological aspect of heaviness is subtle but pervasive, and you notice it in the way your body feels and in the mental effort required to move. Everything is just slightly harder, slightly more demanding, and the cumulative effect over hours and days is fatigue that goes beyond simple muscle tiredness. The mind seems to feel the weight as well, and maintaining motivation and energy levels requires conscious effort and regular rest periods. The settlers here report that adaptation happens over months, and eventually the new gravity becomes normal. But the initial period is marked by constant awareness of the extra load. Looking toward the horizon, you see the landscape extending into the distance, and the hills visible far away are lower and gentler than equivalent features would be on Earth. The geology here is shaped by gravity, with mountains limited in height by the strength of the rock that supports them and slopes constrained by the angle at which materials remain stable. Erosion operates differently as well, with mass movements like landslides and avalanches carrying more energy and causing more dramatic reshaping of the landscape. Rivers would flow faster under the stronger gravitational acceleration, and waterfalls would hit their bases with increased force, carving deeper pools over time. The day-night cycle here is close to Earth normal, with the planet rotating once every 26 hours, and the presence of a regular cycle helps maintain circadian rhythms, despite the challenges of the gravitational environment. The star rises and sets in a predictable pattern, and the transition from day to night provides temporal structure that supports human biological and psychological needs. The night sky, when visible, shows stars that are familiar in their general appearance, but positioned differently than they appear from Earth, reminding you that this world orbits a different star in a different region of the galaxy. The settlement includes exercise facilities, where residents can work to maintain and build the strength needed to function effectively in this gravity. The equipment is designed for high gravity use, with resistance adjusted to account for the increased weight of the user's body. The exercise protocols are more intense than Earth-based programs, and maintaining physical fitness here requires significant time and effort. The alternative is gradual loss of mobility and function, and the community places strong emphasis on physical activity as essential for health and well-being in this environment. The experience of living heavy is one that pervades every aspect of existence on this world, from the way you stand and walk to the way buildings are designed and crops are grown. The gravity is not a feature you can ignore or work around, but a fundamental reality that must be accepted and adapted to. The settlers who choose to stay here long-term are committing to a life where weight is always present, where movement always requires effort, and where the planet itself exerts a pull that is stronger than the homeworld of human evolution. For some, this challenge is part of the appeal, a test of human adaptability and resilience. For others, it is a trade-off accepted in exchange for the other benefits this world offers, including the stability of its star and the resources of its surface. The journey continues to the next destination, where gravity will again differ, but the challenge will take different forms. The craft carries you to a world locked in a gravitational embrace, with its star, and the approach reveals a planet divided into zones by the immutable law that governs its rotation. This world completes one orbit around its red dwarf sun in precisely the same time it takes to rotate once on its axis. And the result is a planet where one hemisphere perpetually faces the star, while the other remains in endless darkness. The landing site has been chosen carefully, positioned in the region where these two extremes meet, the twilight zone, where the star hangs perpetually near the horizon, and temperatures allow for liquid water and potentially for human habitation. Stepping onto the surface, the first thing you notice is the fixed position of the star, and it sits low on the horizon ahead of you, neither rising nor setting, but remaining at a constant elevation above the landscape. The light it provides is angled and reddish, similar to the quality of light during late afternoon on Earth, and the shadows it casts are long and permanent. The features of the landscape, the rocks and hills and valleys, each cast shadows that do not move or change length, and the patterns of light and dark on the ground are as fixed as the terrain itself. This is a world where the sun never moves across the sky, and the concept of a day in the traditional sense has no meaning. The temperature here is moderate, balanced between the scorching heat of the day side and the frozen conditions of the night side. The twilight zone represents the narrow band where these temperature extremes gradient into each other, and the exact position within this band determines the local climate. Closer to the day side, temperatures rise, and the star climbs higher in the sky. Closer to the night side, temperatures drop, and the star sinks lower until it disappears below the horizon altogether. The settlement has been placed in a location where the balance is optimal, where water can exist as liquid, and where temperatures support human activity with appropriate equipment and shelter. Looking toward the day side, you can see the landscape brightening gradually in the distance, and the terrain there is illuminated more fully as the sun rises higher in the sky from that vantage point. The colors shift from the deep reds and browns of the twilight zone toward lighter tones, though still tinted by the red light of the dwarf star. In the other direction, toward the night side, the landscape darkens, and the shadows deepen until the terrain fades into blackness. The gradient is visible and traversable, and walking in either direction would bring you into progressively different climatic zones, all on the same world, all present simultaneously. The wind is a constant and defining feature of this planet, and it blows from the day side toward the night side with remarkable consistency. The air on the day side is heated by constant stellar radiation, and it expands and rises, creating a low-pressure zone. The air on the night side is cold and dense, creating a high-pressure zone, and the pressure gradient drives powerful circulation patterns. The wind you feel now is part of this global flow, moving from hot to cold, and the speed is significant, a steady pressure against your suit that speaks to the immense energy involved in this atmospheric circulation. The wind carries warmth from the day side, and it is the primary mechanism that prevents the atmosphere from freezing out entirely onto the night side. The landscape around you is shaped by the wind, and the terrain shows evidence of erosion patterns that result from the constant directional flow of air. Rock formations have been sculpted into streamlined shapes, with windward faces worn smooth and leeward sides showing deposition of fine particles. The ground is covered in wind-blown dust, and the patterns in the dust reveal the prevailing direction of airflow, with ripples and dunes oriented perpendicular to the wind direction. The geology here is active, not from plate tectonics or volcanic activity, but from the constant reshaping force of moving air. The sky above holds the star fixed in its position, and the quality of light remains constant, unchanging with time, in the way that Earth's light changes through the day. There is no morning, no noon, no evening, no night from this location, only the perpetual late afternoon light that defines the twilight zone. The psychological adjustment to this fixed illumination is one of the challenges for settlers, and the reports indicate that maintaining internal circadian rhythms requires artificial day-night cycles within the habitats. The external environment provides no natural cue for when to sleep and when to wake, and the body's internal clock must be maintained through scheduled lighting and activity patterns. The settlement here consists of habitats designed to withstand the constant wind, and the structures are low, rounded, and anchored deeply into the bedrock below. The architecture minimizes wind resistance, and the exteriors are smooth and streamlined to allow air to flow around them without creating turbulence or excessive force on the walls. Entry airlocks are positioned on the leeward side, sheltered from the direct wind. And protective barriers have been constructed to create calmer zones where equipment and supplies can be stored without risk of being blown away or damaged. Walking forward into the wind, you feel the resistance, and each step requires pushing against the air pressure, as well as lifting your weight against gravity. The experience is different from the high-gravity world, where the challenge was simply the increased weight. Here, the challenge is the moving air, the constant force that makes forward progress in one direction easier than in the other. Turning and walking with the wind at your back, you immediately notice how much easier movement becomes, though the wind's push is unsettling in a different way. A force that propels you forward faster than you intend and requires conscious effort to control your pace. The day side of the planet, beyond the twilight zone, is a place of extremes. The models suggest that temperatures there reach levels where water boils away, where the surface is baked under constant radiation from the star, and where conditions are hostile to life as we understand it. The air is hottest there, and the circulation patterns are driven by the intense heating. Clouds might form near the subsolar point, where evaporation rates are highest, and the moisture could be carried by the winds toward the cooler regions, potentially creating rain in the twilight zone as the air cools and the water vapor condenses. The night side is equally extreme in the opposite direction, and the temperatures there drop to levels where gases freeze and the surface is covered in ice composed of atmospheric constituents. The models suggest that without the wind bringing warmth from the day side, the atmosphere would collapse entirely, with all the air eventually freezing out onto the night side and leaving the planet airless. The circulation prevents this outcome, maintaining a mobile atmosphere that distributes heat and keeps the system in a stable, if divided, state. The night side is a frozen wasteland, dark and cold and silent, and it represents the ultimate destination of the heat that the day side receives continuously from the star. The twilight zone, where you stand, is the region of compromise, where the extremes meet and moderate each other into conditions that allow for complexity and potentially for life. The width of this zone depends on the planet's atmospheric thickness and circulation efficiency, and the models suggest it could range from a narrow band just a few hundred kilometers wide to a broad region covering a significant fraction of the planet's surface. The position of settlement determines what kind of environment the inhabitants experience, and different locations within the zone offer different balances of temperature, wind, and light. The stars visible in the sky above this twilight region include the stars that are always visible and never set, because they are positioned in the part of the sky that this region always faces. Other stars rise and set, not because the planet rotates, but because the planet's orbit around its sun carries it through the year, and the stellar background shifts slowly over the course of that orbital period. The night sky here is strange, with familiar constellations visible in some regions and absent in others, and the stars that are visible change, not with the hours, but with the weeks and months as the planet moves along its orbital path. The concept of time on a tidally locked world is redefined around the orbital period rather than the rotational period, and the year becomes the fundamental unit of time for marking seasons and cycles. The planet's orbit might have enough eccentricity to create variations in the amount of solar radiation received over the course of a year, and these variations could create something like seasons, though the day-night division remains constant. The settlers mark time by the orbital calendar, and the passage of years is the primary way they track duration and plan activities. The settlement's power systems rely on the constant light from the star, and solar panels positioned in the twilight zone receive steady, predictable illumination at a low angle. The energy harvest is less than it would be at the subsolar point, where the star is directly overhead. But the moderate temperatures and wind conditions make the twilight zone more practical for equipment installation and maintenance. The power generated is sufficient for the settlement's needs, and the consistency of the light source means that energy storage for dark periods is unnecessary, simplifying the system design. The agriculture here is conducted within controlled environments, greenhouses that provide protection from the wind and precise control over light, temperature, and humidity. The external environment is too harsh and too constant for open field farming. And the controlled habitats allow for the cultivation of crops using light sources that supplement or replace the red-shifted stellar illumination. The food production is one of the critical factors in the settlement's sustainability, and the success of the agricultural systems determines whether this location can support a permanent human presence, or whether it remains dependent on regular supply shipments from other worlds. The experience of standing in perpetual twilight, feeling the constant wind and seeing the star fixed in the sky, creates a sense of being in a place where normal rules are suspended. The world is divided, locked, and driven by circulation patterns that never cease. The adaptation required to live here is psychological as much as physical, accepting that the sun will never rise, never set, and that the direction of the wind is as permanent as the mountains. The journey continues, and the next world waits with challenges that are different yet again, shaped by the particular conditions of its formation and evolution. The journey brings you to a world where the challenge is not the physical environment itself, but the task of making that environment produce food. And you stand now near the first agricultural facility on a planet that has never known life. The world is a rocky planet, orbiting in the habitable zone of a star similar to the Sun, and the conditions here are close to Earth-like in many respects, with moderate gravity, acceptable temperatures, and an atmosphere that contains oxygen, though not in breathable concentrations, without processing. The ground beneath your feet is soil, in the technical sense, composed of mineral particles weathered from bedrock, but it lacks the organic matter and biological activity that make Earth's soil alive and fertile. The greenhouse structure extends in front of you, a long transparent dome that allows light from the star to penetrate while maintaining internal conditions suitable for plant growth. Inside, rows of plants are visible, green and growing, and the sight of familiar Earth vegetation in this alien landscape is both reassuring and slightly surreal. The plants are crops that humans have cultivated for thousands of years, adapted through generations of selection, but never intended to grow under a sun that is not the sun, or in soil that has never hosted life. The greenhouse is the first step toward making this world productive, toward establishing the agricultural base that any permanent settlement requires. Entering through the airlock, you step into an environment that feels warm and humid compared to the outside air, and the smell of soil and growing plants is immediately noticeable. The aroma is familiar, carrying the earthy tones of organic decomposition and the green scent of photosynthesis, and it speaks to processes that are universal in Earth biology. The plants here are young but healthy, with leaves that are broad and green, and stems that stand upright without signs of stress. The growth is slower than it would be on Earth, possibly due to the different light spectrum or the adjustments required for the local gravity and atmospheric pressure. But the plants are clearly thriving. The soil in the growing beds is not native to this world, but rather a mixture created from local minerals and imported organic matter. And the process of creating this soil was one of the first tasks undertaken when the settlement was established. The native regolith was analysed, and its mineral content was found to include most of the elements that plants require. But the absence of organic matter meant that the soil structure was poor, with low water retention and no microbial activity to cycle nutrients. Compost created from plant waste and other organic materials was mixed with the local minerals, and microorganisms from Earth were introduced to begin the process of creating living soil. The light filtering through the greenhouse dome is full spectrum, coming directly from the star overhead, and the plants receive wavelengths across the visible range and into the ultraviolet and infrared. The star's spectrum is similar to the sun's, but not identical, and the slight differences mean that photosynthesis proceeds at rates and efficiencies that differ from Earth-based agriculture. The plants have adapted to the available light, and the selection of crop varieties included choosing species and cultivars that could function effectively under this star's particular output. The greenhouse panels filter out excess ultraviolet radiation that could damage plant tissues while allowing the photosynthetically active wavelengths to pass through. Walking slowly between the rows, you see several different crop types, including leafy greens, root vegetables, and grain plants that are still in early growth stages. The diversity is intentional, providing nutritional variety and reducing the risk that a single disease or pest problem could destroy the entire food supply. The plants are spaced carefully, with distances calculated to maximize light capture, while allowing air circulation and access for maintenance. The irrigation system is visible overhead, with drip lines that deliver water directly to the root zones, and the water comes from local sources, processed to remove any harmful minerals and adjusted to the pH levels that the crops require. The water on this world exists in subsurface reservoirs, and accessing it required drilling wells that reach down through layers of rock to aquifers below. The water is not salty like Earth's oceans, but rather fresh or slightly brackish, indicating that it has been filtered through rock and not concentrated by evaporation processes. The availability of water is one of the reasons this site was chosen for settlement, and the wells provide a sustainable source that can support both human needs and agricultural irrigation. The water is tested regularly for contaminants, and the processing systems remove any dissolved minerals or compounds that might be harmful to plants or humans. The pollination of flowering crops is a challenge on a world without native insects, and the greenhouse relies on manual pollination techniques and small artificial pollinators that are moved through the plants on scheduled intervals. Some crops are self-pollinating and require little assistance, while others need active intervention to transfer pollen from flower to flower. The process is labor-intensive, and the settlers working in the greenhouse spend significant time performing this task, ensuring that the fruiting crops will develop properly and produce the seeds needed for future plantings. The absence of natural pollinators is one of the many small ways that agriculture here differs from earth farming, requiring human attention to details that would be handled automatically by ecosystems on the home world. The temperature inside the greenhouse is controlled by a combination of passive solar heating and active climate systems that adjust the airflow and humidity. The panels of the dome are designed to trap heat during the day when the star is overhead, and to retain that warmth during the night when the external temperature drops. The diurnal cycle on this planet is roughly 24 hours, close enough to Earth's day length that plants can follow their natural rhythms without significant disruption. The photoperiod, the length of time the plants receive light, is adjusted by shading systems that block sunlight during certain hours, creating the day-night cycles that some crops require for proper development. The first harvest from this greenhouse is approaching, and the anticipation is evident in the careful monitoring and the frequent checks on plant health and maturity. The harvest will be small, measured in kilograms rather than tons, but it represents a milestone in the settlement's journey towards self-sufficiency. The food grown here will supplement the stored provisions brought from Earth, and the psychological value of eating fresh vegetables grown in local soil is significant beyond the nutritional content. The connection to the land, the sense of creating something rather than just consuming imported resources, is an important part of building a permanent community on a new world. The agricultural expansion plans include additional greenhouses and eventually the possibility of open field cultivation if the atmosphere can be modified to support it. The current atmosphere is too thin and lacks the protective ozone layer that Earth's atmosphere provides, and the ultraviolet radiation levels are too high for unprotected plant growth. Terraforming, the process of modifying a planet's environment to make it more Earth-like, is a long-term goal that would take centuries or millennia. But the first steps might include releasing gases that would thicken the atmosphere and introduce oxygen through photosynthetic processes. The plants growing in this greenhouse could be the ancestors of ecosystems that eventually cover this world, transforming it over deep time into a place where humans can walk outside without suits, and where rain falls on fields of grain. The soil microorganisms are thriving in the greenhouse beds, and the microbial populations include bacteria and fungi that were carefully selected from Earth's agricultural soils. These organisms perform functions that are essential for plant health, including nitrogen fixation, phosphorus solubilization, and the decomposition of organic matter into forms that plants can absorb. The microbial community is still developing, and the diversity is lower than in mature Earth soils, but the foundational species are present and reproducing. The monitoring systems track microbial activity through soil respiration measurements and nutrient cycling rates, and the data indicates that the biological processes are establishing successfully. The energy required to operate the greenhouse and its support systems comes from solar panels positioned outside, and the power demand is significant, including the water pumps, climate control, lighting supplements for areas that do not receive direct sunlight, and the monitoring equipment. The settlement's energy budget allocates a substantial portion to agriculture, reflecting the priority placed on food production as a foundation for long-term survival. The efficiency of the systems is continually optimized, and innovations developed here might eventually be shared with other settlements on other worlds, building a knowledge base of exoplanetary agriculture. The genetic diversity of the crops is maintained through careful seed saving and storage, and the seed bank includes varieties that are not currently being grown but might be needed if conditions change or if different nutritional needs arise. The seeds are stored in controlled conditions with low temperature and humidity to preserve viability for years or decades. The knowledge of how to save, select, and plant seeds is transmitted through training programs, ensuring that the skills required for agriculture persist across generations and are not lost if supply lines from Earth are interrupted or discontinued. The settlers working in the greenhouse move through the rows with practiced efficiency, checking plants for signs of disease or pest problems, adjusting irrigation lines, and recording data on growth rates and development stages. The work is hands-on and detailed, requiring both scientific knowledge and practical farming skills. The workers are a mix of specialists with backgrounds in botany and agriculture, and generalists who have learned these skills since arriving on this world. The community's survival depends on the success of these efforts, and the responsibility is taken seriously by everyone involved. The next challenge on the horizon is the introduction of protein sources, and the plans include aquaculture systems for fish and insect farming for additional protein and nutrient cycling. The fish would be raised in tanks using recirculated water systems, and the waste from the fish would provide nutrients for the plants in a symbiotic arrangement. The insects, likely crickets or mealworms, would convert plant waste into high-quality protein and could be used as food directly or as feed for fish and other animals. These systems are in the planning and construction phases, and their implementation will diversify the food supply and reduce dependence on imported protein sources. The experience of standing in this greenhouse, surrounded by green growing things on a world where green has never existed before, is profound in a quiet, understated way. The plants are not native, and the soil is partly artificial, but the life here is real and sustained by the star overhead and the water from the planet below. The connection between human effort and the production of food is visible and immediate, and the work creates a bond between the settlers and this place that goes beyond simply inhabiting it. They are changing this world, slowly and carefully, growing the first gardens in soil that has been sterile for billions of years. The journey continues, and the next destination will explore time and its passage on worlds where the rhythms differ from those that shaped human evolution. The journey takes you to a world where the calendar operates on a scale that feels accelerated compared to the year you knew on Earth, and the planet circles its star in a period that measures just 16 Earth days from one completion to the next. The orbital speed is high, driven by the close proximity to the star, and the result is a year that passes more than 20 times faster than Earth's annual cycle. You arrive during one of these rapid transits around the star, and the concept of time on this world requires immediate adjustment and recalibration of your expectations about how long things take and how age is measured. The planet itself is slightly smaller than Earth, and the star it orbits is a red dwarf, cooler and dimmer than the Sun. The close orbit places the planet within the habitable zone despite the star's lower energy output, and the surface conditions are moderate, with temperatures that allow liquid water to exist, and an atmosphere that provides pressure and composition within acceptable ranges for human activity. The gravity is slightly lower than Earth's, making movement easier and reducing the physical strain that characterized the high-gravity world you visited earlier. The overall environment is surprisingly comfortable, and the primary adjustment is not physical, but temporal. Standing on the surface, you can feel the passage of time in a way that is impossible on longer-period worlds, and the star's position in the sky shifts noticeably over the course of hours. This world is not tidally locked, and the rotation period is roughly 30 hours, creating a day-night cycle that is close to familiar, but combined with the rapid orbital motion, creates a complex pattern of seasonal and daily changes. The star rises and sets with each rotation, but the position of sunrise and sunset shifts along the horizon as the planet moves through its orbit, creating seasonal variations that cycle through in just 16 days. The settlement here operates on a dual calendar system, with local time based on the planet's rotation and year, and Earth time maintained for coordination with other settlements and for tracking the ages and schedules of residents who were born elsewhere. The local year is divided into units that might be called months or weeks, depending on preference, and the rapid cycling means that seasonal celebrations and markers occur frequently. The community has adopted traditions that acknowledge each completed orbit, creating a rhythm of observance that is unfamiliar but meaningful for those who have lived here long enough to internalize the local timekeeping. Walking toward the habitat complex, you notice markers indicating the current local date, and the display shows that this is the third day of the 11th local year since the settlement was established. In Earth terms, the settlement is only a few Earth years old, but the local calendar has already accumulated multiple cycles, and children born here have accumulated local ages that are numerically high despite their actual time since birth being relatively short. A child who is 2 Earth years old might celebrate their 48th local birthday, and the discrepancy creates interesting questions about how age and maturity are understood and recognized in this community. The star overhead is dim compared to the sun, and the light quality is red-tinted, as expected from a red dwarf. But the rapid orbital motion means that the angle of illumination changes noticeably over periods of days. The seasons here are subtle, determined by small eccentricities in the orbit that bring the planet slightly closer to and farther from the star during each cycle. The temperature variation is modest, perhaps a few degrees across the full range, but the settlers can detect the difference and have learned to recognize the patterns. The warmest point in the orbit is marked on the calendar, as is the coolest point, and the community plans activities around these predictable variations. The agricultural systems here are adapted to the rapid year, with crop cycles that match the local seasonal rhythms. Some plants are grown through multiple local years, with planting and harvesting timed to specific points in the orbital calendar. Other crops complete their life cycles within a single local year, growing from seed to maturity in just over 2 Earth weeks. The accelerated agriculture creates opportunities for rapid iteration and selection, and plant breeders working here can develop new varieties much faster than would be possible on Earth, where each generation requires a full Earth year or more. The greenhouse records show dozens of planting and harvest cycles completed in the time since establishment, and the crop yields have improved steadily with each iteration. The psychological experience of time here is one of the most frequently discussed topics among the settlers, and the reports indicate that adaptation varies widely between individuals. Some residents appreciate the rapid cycling, finding that the frequent completion of orbital periods creates a sense of momentum and progress. Others find the pace disorienting, feeling that time moves too quickly and that the passage of local years does not correspond to their internal sense of how much life they have lived. The maintenance of Earth time as a parallel system helps anchor individuals who struggle with the local calendar, providing a connection to the slower rhythms of the home world. Children born on this planet represent a unique case study in temporal perception, and the few who have been born here are being observed carefully to understand how they develop a sense of time and duration. The hypothesis is that they will internalize the local rhythms as natural and normal, and the rapid cycling of seasons and years will be their baseline for understanding temporal progression. Their birthdays arrive frequently by local count. At the intervals between birthdays, measured in days, are consistent with childhood development timescales. The question of how these children will relate to Earth time, if they ever visit that world, is an open one, and the potential for confusion or disconnect is recognized as a challenge for future integration. The star's path across the sky changes position with each passing day, and the sunrise point on the horizon shifts noticeably over the course of a local week. The movement is analogous to the seasonal variation in sunrise and sunset positions on Earth, but compressed into a much shorter time frame. The residents have learned to navigate by the star's position, using it as a directional reference that must be adjusted mentally for the current point in the orbit. The stellar motion is predictable and calculable, and the settlement's navigation systems provide real-time corrections for anyone needing precise directional information. The night sky also changes rapidly, with constellations rising earlier each night as the planet progresses around its orbit. The stars visible in the evening sky at the beginning of a local year are different from those visible at the end of that year, and the full cycle of stellar visibility completes in just 16 days. Astronomy enthusiasts in the settlement have taken advantage of this rapid cycling to observe phenomena that might require a full Earth year to become visible from a slower orbiting planet. The changing sky provides continuous variety, and the residents can watch the progression of the galaxy's apparent rotation through a full cycle in the time it would take Earth to complete half a month. The communication with Earth and other settlements is complicated by the rapid local time progression, and messages that reference local dates and times require conversion to be understood by recipients who use different calendars. The settlement has adopted a policy of dual dating all communications, providing both local and Earth standard timestamps to avoid confusion. The language around time has evolved to include qualifiers like local years and standard years, and the community is careful to specify which system they are using when discussing durations, ages, or schedules. The energy systems here benefit from the rapid orbital cycling, as the changing distance from the star creates variations in solar input that average out over each orbit. The solar panels receive slightly more energy at perihelion, the closest approach to the star, and slightly less at aphelion, the farthest point. But the variation is manageable, and the systems are designed to handle the fluctuation. The energy storage systems buffer the differences, and the net effect is a stable power supply that supports the settlement's needs without requiring excessive battery capacity or backup systems. The concept of long-term planning on this world is redefined by the rapid calendar, and projects that would take years on Earth might be measured in dozens or hundreds of local years here. The construction of new habitat modules, the expansion of agricultural facilities, and the development of infrastructure are all planned using local timescales, and the rapid progression creates a sense that milestones are reached frequently. The community celebrates these milestones regularly, marking completions and achievements that accumulate quickly on the local calendar, even as the actual time investment remains substantial. The settlers who choose to remain on this world long-term are accepting a future where their local age will far exceed their biological age. And the number of local years they accumulate will be a badge of connection to this place, rather than an accurate reflection of their life experience. An elder in this community might reach a local age of 1,000 years within a few Earth decades, and the symbolic weight of that number is discussed and celebrated even as everyone understands that the biological reality is different. The rapid accumulation of years creates a unique cultural identity for this settlement, where time is counted differently and the rhythm of life is set by an orbital period that Earth never prepared humans to experience. The journey now takes you to meet the individuals who represent something unprecedented in human history, and you find yourself in a habitat common area where children are playing, their laughter and movement filling the space with energy and life. These children were born on worlds beyond Earth, and for them, the landscapes and skies and gravity you have been experiencing as alien and remarkable are simply normal, the only reality they have ever known. Their existence answers a question that was theoretical until the moment of their births, confirming that human reproduction and development can occur on other planets, and that our species can truly become multi-world. The children range in age from infants to pre-adolescence, and they move through the habitat with a confidence and ease that reflects their adaptation to this environment. The gravity here is lower than Earth's, roughly 80% of the familiar pull, and the children have grown in this reduced field from conception through development. Their movements show the effects of this upbringing, with jumps that carry them higher and longer than Earth children could achieve, and a physicality that is adjusted to the reduced weight of their own bodies. They laugh and play games that would be impossible or dangerous in Earth gravity, and their spatial awareness is calibrated to the reality of this world. Watching them, you can see both the universal qualities of childhood and the specific adaptations to the local conditions. The games they play involve movements and strategies that take advantage of lower gravity, and the equipment designed for their use is scaled and engineered for the forces and accelerations that this world allows. The children born here have never experienced Earth gravity, and the stories they hear about a world where everything is heavier and jumping is harder seem to them like descriptions of a place where movement would be difficult and uncomfortable. Their baseline is here, and Earth is the exotic location that exists only in images and descriptions. The development of these children has been monitored carefully, and the medical data shows both expected and unexpected variations from Earth-based developmental norms. Physical milestones, like walking and running, were reached at different ages, with some skills developing earlier due to the reduced gravitational load, and others developing later due to the different muscle engagement required. Bone density is lower than Earth norms, an expected adaptation to reduced gravitational stress, but the bones are structured differently, with thickness and cross-sectional shapes that provide adequate strength for the forces they experience. The long-term health implications are still being studied, and the question of whether these children could safely visit Earth and handle the higher gravity is an open area of research. The cognitive and psychological development appears to follow patterns similar to Earth children, with language acquisition, social bonding, and learning progression occurring on familiar timescales. The content of their knowledge is different, shaped by the environment they live in and the priorities of this community. But the processes of curiosity, exploration, and meaning-making are recognizably human. They ask questions about their world, about the stars, about Earth, and about why things are the way they are. Their questions reflect their experiences, and they wonder about things that Earth children never think to question, like why the sky is a certain color here, or why the star looks different in images from Earth. One child approaches you with curiosity, and the child is comfortable in the suit and helmet that all residents wear outside the habitat areas, moving with practiced ease through the motions of greeting and interaction. The child asks where you are from, and when you mention traveling between worlds, the child's eyes widen with interest. For this child, travel between planets is a real thing that adults do, and the distances involved are understood in the abstract terms of light years and travel time. Concepts introduced early in the education here, because they are relevant to the reality of multi-world existence. The child shares that they have never seen Earth, but have seen pictures and videos. And Earth looks beautiful, but also very different from home. The concept of home for these children is unambiguous, and it is the world they stand on, the gravity they grew in, the star they see in the sky. Earth is a place their parents came from, a location of historical and familial significance, but it is not home. The psychological implications of this shift are profound, marking the first generation for whom humanity is not synonymous with Earth, for whom being human does not require being from Earth. The children are human by biology and culture, but are natives of another world, and their identity formation includes elements that no previous generation of humans could claim. The education these children receive includes knowledge about Earth, its geography, history, and ecosystems, but it is taught as information about a distant place rather than as the default reference point for all understanding. They learn about oceans and forests and animals, and these concepts are interesting and valuable, but not directly relevant to their daily lives. They also learn about their own world, its characteristics, its challenges, and the work that their community does to thrive here. The curriculum includes practical skills for living in this environment, and the children are taught from an early age how to operate in reduced gravity, how to maintain the equipment that supports life, and how to contribute to the community's sustainability. The language these children speak is the same language as their parents, with vocabulary and grammar carried from Earth. But the words they use most frequently and the concepts they discuss daily are shaped by their environment. They have words for local features, local weather patterns, and local activities that are specific to this world, and some of these words are borrowed from technical terminology or created anew by the community. The linguistic evolution is subtle but ongoing, and over generations the language might diverge further, developing characteristics that reflect the unique experiences and needs of this population. The parents of these children carry a dual perspective, remembering Earth and adapting to this world, and they watch their children grow with a mixture of pride and sometimes wistfulness. The parents understand that their children will never fully grasp what Earth was like, and the sensory memories of Earth's blue sky, the smell of rain on soil, the sound of birds, the feeling of Earth's gravity, are things that cannot be fully transmitted through description. The parents preserve what they can through stories, images, and traditions, but they also recognize that their children are creating their own culture, one that is rooted in the reality of this place. The healthcare for these children includes considerations that are specific to their developmental environment, and the medical staff monitors growth patterns, bone development, cardiovascular function, and other systems that might be affected by the reduced gravity and different atmospheric composition. The data collected here contributes to a growing body of knowledge about human development in space and on other worlds, and the findings are shared with other settlements and with researchers on Earth. The children are, in a sense, pioneers themselves, providing through their growth and health the information that future generations will use to refine and improve the conditions for raising children on exoplanets. The social dynamics among the children include the formation of friendships, conflicts, resolutions, and the hierarchies and alliances that characterize childhood social groups everywhere. The specifics are influenced by the small population size and the close quarters of habitat living, but the patterns are recognizable. The children form bonds based on shared interests, proximity, and personality compatibility, and they navigate the complexities of social relationships with the same mix of intuition and learned behavior that children everywhere employ. The adults support this social development, providing guidance and structure, while allowing the children the freedom to develop their own social world. The future of these children is both certain and uncertain, and the paths available to them will depend on choices they make as they grow, and on opportunities that arise as the settlement matures. Some might remain on this world, contributing to the community and eventually raising their own children here, continuing the line of natives who know no other home. Others might choose to travel, to visit Earth or other settled worlds to experience different gravities and skies and cultures. The freedom to choose is an ideal that the community values, but the practicalities of interstellar travel and the physical challenges of adapting to different gravities mean that choices are constrained by reality. The children represent hope in a tangible form, evidence that the human presence on other worlds is not temporary, but can be sustained across generations. Their existence validates the efforts of the first settlers, the risks taken and the hardships endured, by demonstrating that those efforts have created not just a settlement, but a new human home. The children born here carry forward the human story into environments that Earth never touched. And they are the first of what could eventually be millions or billions of humans who live on worlds orbiting stars across the galaxy. The journey continues, moving now to the experience of looking upward from these new homes and seeing the cosmos from perspectives that Earth never offered. The night has settled over the region where you stand, and the star has dipped below the horizon. And now the sky above reveals the universe in a configuration that no human saw until settlements were established on worlds beyond the solar system. The darkness is complete in the absence of artificial light, and your eyes adapt slowly to the faint illumination from the stars themselves. The sky is filled with points of light, thousands of them visible from this dark location, without atmospheric interference or light pollution. And the patterns they form are unfamiliar, lacking the constellations that human cultures developed over millennia of observation from Earth. The planet you stand on orbits a star roughly 30 light-years from Earth, far enough that the perspective shift is significant and near enough that the journey was possible with technologies developed over the past centuries. The stellar neighborhood looks different from this vantage point, and the stars that were prominent in Earth's night sky are either absent, displaced, or diminished, depending on their actual positions in three-dimensional space. The familiar patterns are gone, and in their place is an arrangement of stars that is unique to this location. Patterns that the settlers here are beginning to name and recognize as their own constellations. Looking toward the region of sky where you know Earth's sun should be, you search for the familiar star, and the task requires reference to a chart because the sun does not stand out from this distance. Through the optical aid provided by a small telescope, you locate the star, and it appears as an unremarkable point of yellow-white light, faint but visible, one star among many in this particular section of sky. The sun is a fifth magnitude star from this distance, barely visible to the unaided eye under perfect conditions, and easily overlooked without knowing exactly where to look. The star that anchored every human civilization until recent centuries now appears ordinary, indistinguishable from hundreds of other stars in the same visual field. And the only thing that makes it significant is the knowledge of what orbits it. You lower the telescope and look at the spot where the sun sits, and without optical aid, the star blends into the background, lost in the general scatter of stellar light across the sky. Everything you left behind orbits that faint point, and everyone who did not make the journey to this world continues their lives in a system centered on that distant, dim speck. The emotional weight of seeing it reduced to such insignificance varies among the people here, and some find comfort in knowing it remains visible, while others feel the distance more acutely when confronted with how small and far it appears. The patterns overhead begin to resolve as your eyes fully adapt, and certain stars stand out due to their brightness or color, and these become the natural anchors around which new constellations are forming. A particularly bright blue-white star sits high in the current season's evening sky, and the settlers have begun calling it the Beacon, using it as a directional reference, much as Earth's navigators used Polaris. The star is actually closer to this world than to Earth, and its prominence in the sky makes it a natural focal point for orientation and storytelling. To the west, a cluster of reddish stars forms a rough arc that some residents have named the Bridge, and children born here are learning these patterns as naturally as children on Earth learned the Big Dipper or the Southern Cross. The names are still informal, not yet standardized, and different groups within the settlement sometimes use different terms for the same formations, a process that mirrors the early development of constellation naming in Earth's ancient cultures. Over time, consensus will likely emerge, and these patterns will become part of the cultural identity of people who call this world home. The Milky Way stretches across the sky, and its appearance is altered by the change in viewing angle. And the bright central bulge of the galaxy sits in a different position relative to the horizon and the celestial equator. From Earth, the galactic center lies toward the constellation Sagittarius, and it rises and sets with the seasons. But from this world, the geometry is different, and the dense star fields of the galactic core appear in a region of sky that has no correspondence to Earth's traditional constellations. The band of light is still beautiful, still the visible disk of the galaxy seen edge on, but its path across the sky follows a new trajectory. You turn slowly, scanning the full dome of the sky, and the sense of reorientation is profound. A reminder that Earth's view of the universe was particular to one location, and that every star system offers a unique perspective. The stars that appear close together from Earth may be separated by dozens of light years in actual space, and from this new vantage point, those alignments are broken, the illusion of proximity dissolved by the change in viewpoint. Stars that were invisible from Earth due to their position may be prominent here, and stars that dominated Earth's skies may be dimmed by increased distance or blocked entirely by interstellar dust clouds. Above you, two of this system's other planets are visible as bright points that do not twinkle, and their steady light distinguishes them from the stars, just as Venus and Jupiter stood out in Earth's skies. One is a gas giant orbiting farther from the star, and it appears as a brilliant white object that moves slowly against the background stars over the course of weeks. The other is a smaller rocky planet closer to the star, visible only in the early evening or pre-dawn sky, depending on its position in its orbit, and it shows phases when viewed through a telescope, sometimes appearing as a crescent and sometimes as a nearly full disk. The settlement has no moon, and the absence is one of the details that marks this world as fundamentally different from Earth, despite its many similarities. The night sky lacks the bright disk that humans watched and measured for thousands of years, and there are no lunar phases to mark the passage of time, no monthly cycle visible in the heavens. The psychological impact of the missing moon is subtle but real, and many settlers report that the night sky feels emptier without it. even with the richness of stars and planets visible overhead. The stars themselves span the full range of colors observable to human eyes, and the variety becomes apparent once you begin looking carefully at individual points of light. Most appear white or pale yellow, but scattered among them are stars that glow distinctly red, orange, blue, or even faintly green depending on their surface temperatures and the sensitivity of your vision. The blue-white stars are young and hot, burning their fuel quickly, and the red stars are either cool, low-mass stars that will burn for trillions of years, or massive stars nearing the end of their lives. Their outer layers expanded and cooled into the red giant phase. The dome of the sky here follows the same basic rules as Earth's sky, and the planet's rotation carries the stars from east to west over the course of the night. And the annual orbit around the star causes different regions of sky to be visible at different seasons. The celestial mechanics are unchanged, governed by the same laws of motion and gravity. But the specific details are unique to this world, and the length of the day and year differ from Earth's familiar rhythms. The sidereal day here is slightly shorter, and the stars complete their nightly journey a bit faster than they did on Earth, a difference that becomes noticeable when you watch the sky for extended periods. You locate a particularly bright star near the eastern horizon and watch it rise, and the motion is perceptible if you remain still and patient, the star gradually climbing higher as the planet rotates beneath the fixed dome of the distant universe. The act of watching the stars move is calming, a meditation on cosmic scale and planetary motion, and it connects you to countless generations of humans who watch the same process from Earth, even though the specific stars and patterns are different. The fundamental experience of standing on a rotating planet beneath a vast universe remains the same. Some of the stars you see are undoubtedly orbited by planets of their own, and statistical studies of exoplanet occurrence suggest that nearly every star hosts at least one planet, and many hosts several. Among the thousands of visible stars, hundreds likely possess rocky worlds in habitable zones, and some percentage of those may support conditions suitable for life, whether microbial or complex. The settlers here sometimes wonder if inhabitants of those distant worlds are looking back, seeing this system's star in their own skies, perhaps standing on their own new worlds and contemplating the same questions. The temperature has dropped as the night progresses, and the air around you carries the coolness that comes once the star's warmth has fully dissipated, and you can see your breath forming faint clouds in the starlight. The settlement's lights are visible in the distance, a small cluster of illumination that marks the human presence on this world, and their glow is warm against the cold vastness of the sky. The contrast between the artificial lights and the natural darkness is sharp, and it emphasizes both the smallness of the human foothold here and the determination required to establish and maintain it. Walking back toward the settlement, you glance up once more at the unfamiliar constellations, and the names given to them by the people here are starting to feel natural. Less like provisional labels and more like genuine identifiers. The beacon, the bridge, the navigator's triangle, the distant shore, each name reflecting something about the experience of living here, or the process of arriving and adapting. These patterns will be taught to children, referenced in navigation, woven into stories, And over generations, they will become as embedded in this culture as Orion or Cassiopeia were in Earth's cultures. The sky above this world will never match Earth's sky, and the stars will never form the familiar shapes, and the moon will never rise, and the sun will never be more than a faint, distant point, requiring instruments to identify. Yet the sky is no less beautiful for its strangeness, and the settlers are learning to find orientation and meaning in its unique patterns, creating a new relationship between humanity and the cosmos from a perspective no previous generation could access. The view from here is different, and it is becoming home. And as the stars continue their slow rotation overhead, there is another aspect of distance that defines life on this world, one that goes beyond light years and unfamiliar constellations, a gap measured not just in space but in time, and it shapes every communication, every message, every attempt to maintain connection with the civilization that still orbits that faint, distant star. The communication terminal sits in a quiet room near the center of the settlement, and the interface is simple, designed for recording messages that will be compressed, transmitted, and received years after they are sent. You sit before the screen, preparing to record a message to family on Earth, and the process has become familiar over the years you have lived here, though it never stops feeling strange. The words you are about to speak will not be heard for decades, and any response will take decades more to return. And the conversation you are having spans a length of time that makes real dialogue impossible. The distance between this world and Earth is roughly 30 light years, and light is the fastest thing in the universe, and even moving at that ultimate speed, information takes 30 years to cross the gap. A message sent today will arrive in Earth's communication networks 30 years from now, received by people who have aged 3 decades since you left, living in a world that has continued to change and evolve without you. Their reply, if they send one, will take another 30 years to return, and you will be 60 years older than you are now when you hear their response to the words you are about to record. You activate the recording system, and the indicator light confirms that the message is being captured, and you begin speaking, choosing words carefully because there is no opportunity for clarification or follow-up within any reasonable time frame. You share news about your life here, updates on the settlement's progress, descriptions of the landscape and the work being done. Small personal details that might maintain a sense of connection despite the vast separation. The act of speaking feels normal, but the knowledge that these words will travel for 30 years before being heard gives them a weight that ordinary conversation never carries. When you finish, you save the recording, and it joins a queue of other messages waiting to be transmitted during the next scheduled communication window. When the settlement's main antenna is aligned properly and the power systems can support the transmission, the data will be converted to a tightly focused beam of electromagnetic radiation, and that beam will propagate outward at the speed of light, crossing the empty space between stars, passing through regions that contain almost nothing, traveling for 3 decades before reaching the receivers in Earth's solar system. The message is already old the moment you finish recording it, frozen in time while you continue to age and change. The previous message you sent was recorded 4 years ago, and it is still in transit, only a fraction of the way to Earth, propagating through the void with patient inevitability. The message before that was sent 9 years ago, and it still has 2 decades of travel remaining before it reaches its destination. You have sent dozens of messages since arriving here, and none have been received yet, and the earliest ones will not arrive for another 26 years. Every message you have ever sent from this world is still traveling, still en route, and you will likely be elderly before any of them are heard. The replies you are waiting for have not been sent yet, because the messages that would prompt them have not arrived, and the entire exchange is delayed by the absolute cosmic speed limit. You sent a message to your sister 7 years ago, telling her about the first year of settlement, describing the initial explorations and the challenges of establishing infrastructure. And that message will reach her 23 years from now. She will be in her 70s when she hears it, and you will be in your 60s when you sent it. But by the time her reply returns, you will be past 90, if you live that long. You think about the conversations that are unfolding in this stretched, distorted time frame, and the strangeness of the situation is difficult to fully internalize. A question you asked years ago will be answered decades in the future, and by the time the answer arrives, the question may no longer be relevant, and you may have found the answer yourself through experience, or the circumstances may have changed entirely. Advice requested cannot be received in time to be useful, and shared experiences are always out of sync. Celebrations and sorrows separated by years of travel time, even though they are communicated as quickly as physical law allows. Some settlers maintain the practice of regular messages, recording updates every few months or once a year, building a narrative of their lives here that will eventually be received as a compressed chronicle spanning decades. Others have stopped sending personal messages, finding the delay too disorienting or emotionally difficult, and they contribute only to the scientific and technical reports that the settlement transmits to share data and findings. The psychological experience of communication delay is individual, and people adapt to it differently. Some finding meaning in the ritual of recording messages, and others finding frustration in the impossibility of real exchange. The younger residents, particularly those born here, have a different relationship to the delay, and for them, Earth is already an abstraction, a place they have never seen except in images and recordings, and the idea of waiting decades for a response is simply how communication with Earth works. They record messages to relatives they will never meet in person, grandparents or cousins who exist only as voices and images transmitted across light years. And the asynchrony is not strange to them, because they have never known anything different. Their expectations are calibrated to the reality of interstellar distances. A message arrives from Earth during your visit to the communication center, and the alert is met with immediate attention because incoming messages are rare and significant events. The message was sent 29 years ago, shortly after the colony ship departed, and it contains updates and farewells from people who knew the mission was beginning and wanted to send words of encouragement and hope. The message is nearly 3 decades old, recorded by people who are now much older or possibly deceased, and it carries news from a world that has changed profoundly in the years since it was sent. You listen to the message, and the voices are familiar but younger, and the content is both touching and irrelevant, offering advice for challenges that were faced and resolved years ago, expressing hopes for outcomes that have already occurred. The disconnect is jarring, a reminder that Earth's knowledge of this settlement is decades out of date, and their understanding of what life here is like is based on information that was already old when it was sent. They do not know what the settlement looks like now, what has been built, what has succeeded or failed, because all of that happened after their last information about this world was received. The settlement has developed protocols for decision-making that account for the communication delay, and the guiding principle is autonomy. The recognition that waiting for consultation or approval from Earth is not feasible for most situations. Problems must be solved locally, using the expertise and resources available here, and the colony operates as an independent entity by necessity, even though it maintains cultural and emotional ties to Earth. The delay enforces self-reliance in a way that no policy or intention could, and it shapes the character of the community. Scientific data flows in both directions, and the delay is less problematic for information that is not time-sensitive. And discoveries made here are transmitted to Earth, where they will eventually be received and analyzed by researchers decades in the future. Similarly, new findings and technological developments from Earth are transmitted outward, and the settlement receives updates on scientific progress, cultural changes, and historical events, all arriving 30 years after they occurred. The information is valuable even when delayed, and the exchange continues despite the temporal gap. You record another message, this one addressed to researchers on Earth, describing recent observations of the local star's behavior and measurements of planetary atmospheric composition. The data will be useful whenever it arrives, and the delay does not diminish its scientific value. And you take care to be thorough and clear, knowing that you will not be available to answer questions or provide clarification for 6 decades. The message is complete and self-contained, anticipating potential questions and providing context and methodology alongside the raw data. The experience of living with communication delay is one of the defining features of interstellar settlement, and it separates this endeavor from any previous human exploration or colonization. Antarctic researchers could communicate with the rest of the world in real time, and even astronauts on the Moon experienced only a few seconds of light-speed delay. Here, the delay is measured in decades, and it creates a form of isolation that is not physical but temporal, a separation in time that is as profound as the separation in space. As you leave the communication center, you carry the knowledge that the messages you sent today will travel for the rest of your active life and beyond. And the responses, if they come, will arrive when you are old or possibly after you have died. The words you spoke will outlive your ability to hear the replies, and the conversation you initiated will be completed, if at all, by others. The connections are maintained not for practical benefit, but for continuity, for the preservation of relationship across a gap that strains the very concept of relationship, for the assertion that distance and time do not sever the bonds between human beings, even when they make real exchange impossible. And yet, despite the isolation, despite the impossibility of dialogue, the settlement endures and grows. And the people here build lives that are not defined by waiting for messages or yearning for Earth, but by the immediate reality of this world and the community that shares it. A community that is slowly becoming something new. The plaza at the center of the settlement is filled with activity, and the sounds of human life echo across the open space. Voices conversing, children playing, equipment operating, the ordinary noise of a functioning community. You stand near the edge, watching the flow of people moving between buildings, and the scene is unremarkable in its familiarity, the kind of everyday activity that happens in any human settlement. Yet, it is occurring on a world that had no human presence at all until a few decades ago. The transformation from empty planet to inhabited place is complete enough that the strangeness has faded, replaced by routine and normalcy. The buildings around the plaza represent multiple generations of construction, and the differences are visible in their design and materials. The earliest structures are functional and compact, built quickly from prefabricated components brought on the colony ship, and they prioritize survival and basic shelter over comfort or aesthetics. Later buildings show more ambition, constructed using locally sourced materials and adapted to the specific conditions of this world, and they reflect growing confidence and permanence. The newest structures are the work of architects who were born here, and their designs incorporate elements that have no reference to Earth, shapes and forms that respond to this world's particular gravity, atmosphere, and light. Children run across the plaza, and their movements are natural and easy, and they navigate the local gravity without thought or effort because it is the only gravity they have ever known. Some of them are third-generation residents, grandchildren of the original settlers. And for them, Earth is not a memory or even a distant home, but simply a historical origin, a place their grandparents came from, significant but abstract. They speak the same language, carry the same genetic heritage, but their lived experience is entirely rooted in this world, and their sense of normal is calibrated to conditions that the first generation found alien and challenging. An older woman sits on a bench near the center of the plaza, and you recognize her as one of the original settlers, someone who made the journey as a young adult and has now lived on this world for more than 40 years. Her hair is grey, her movements slower than they once were, and she watches the children play with an expression that might be contentment or might be something more complex. A mixture of satisfaction at what has been built and perhaps a trace of longing for what was left behind. She has spent more of her life here than she did on Earth, and yet Earth remains part of her identity in a way it never will for the children. You join her on the bench, and she nods in greeting, and the two of you sit quietly for a moment, watching the activity around you. She mentions that the plaza used to be just empty ground, marked with flags to indicate where the central area would eventually be, and she remembers when every structure was temporary and every system was experimental. The settlement has succeeded, she says, not because it was easy or because everything went according to plan, but because the people here committed to making it work and adapted when challenges arose. And now it is simply home. The conversation turns to the changes that have occurred over the decades, and she describes the early years when everything was uncertain and every small failure felt potentially catastrophic. The first successful harvest was celebrated with the intensity that seems disproportionate now, but at the time it represented proof that sustained life here was possible, that the settlement would not be dependent on dwindling supplies from Earth. The first child born here was another milestone, evidence that human biology could function across generations in this environment. And each birth since has reinforced that confidence. The settlement's population has grown slowly, and it remains small by Earth standards, numbering only a few thousand people. But the growth has been steady, and the community is stable. Some residents arrived on later missions, bringing new skills and genetic diversity, and the inflow of new people has continued at irregular intervals as additional ships complete the long journey from Earth. Each arrival brings news that is decades old, and faces that are familiar from images but not from experience. Family members who aged during the journey. Friends who left Earth years after the first wave but arrived only recently in local time. The economic and social systems here have evolved to fit the constraints and opportunities of this environment, and some structures mirror Earth's historical patterns, while others are entirely novel. The settlement operates on principles of shared resource management and collective decision-making, necessary in a small, isolated population where individual survival depends on community function. And the culture reflects values of cooperation, adaptability, and long-term thinking. Conflicts arise, as they do in any human group, but the awareness that everyone's survival depends on the settlement's success creates strong incentive toward resolution and compromise. She points to a young couple walking across the plaza, and she mentions that they were both born here, and they recently formed a partnership and are expecting their first child. And that child will be fourth generation, someone whose great-grandparents made the original journey, but whose own entire ancestry on this world will span nearly a century. The generational progression is beginning to create a genuine local history, a narrative that is specific to this place, and the settlers are conscious of being the early chapters in a story that will continue long after they are gone. The woman speaks about her own family, children and grandchildren who live here, and she expresses a quiet pride in what they have accomplished, but also a recognition of what was given up to make this possible. She will never see Earth again, and she has accepted that, and most days she does not think about it. But occasionally something will trigger a memory or a sense of loss, and she will feel the weight of the distance and the finality of the choice she made. Her grandchildren do not carry that weight, she says, and that is probably as it should be, because they are building their lives here without the burden of comparison or regret. You ask if she would make the same choice again, knowing what she knows now, and she is quiet for a moment before answering. She says yes without hesitation, but she also acknowledges that the question is complicated because the choice was made by a younger version of herself, with different priorities and incomplete information. And the person she has become through living here is not quite the person who made the decision. The settlement has shaped her as much as she helped shape it, and she is profoundly different from who she would have been if she had stayed on Earth. And there is no way to separate the choice from the life it produced. The light is beginning to fade as the local star approaches the horizon, and the sky takes on the colors of sunset. Though the specific hues are distinct from Earth's sunsets, due to the atmospheric composition and the star's spectral output. The children are called inside by parents, and the plaza gradually empties, and the settlement transitions toward evening routines. Lights coming on in windows, the sounds of meal preparation, the rhythms of domestic life that are universal across human cultures, regardless of which planet they occur on. You stand and prepare to leave, and the older woman remains on the bench, and she says she often sits here in the evenings, watching the settlement wind down, appreciating the ordinariness of it all. The fact that daily life has become ordinary here, on a world that was lifeless and untouched for billions of years, is itself extraordinary, she says. But it is an extraordinariness that you have to step back to see, because from inside it, everything just feels like life, like home, like the place where things happen and where people belong. Walking back toward your own quarters, you pass structures that house families, workshops, greenhouses, storage facilities, all the infrastructure of a functioning society. And the settlement extends beyond what you can see from here, with outer sections devoted to agriculture, resource extraction, power generation, research facilities. The footprint is still small compared to cities on Earth, but it is growing, and projections suggest that within a few more generations, the population could number in the tens of thousands if growth continues and if conditions remain stable. The stars are beginning to appear overhead, and the unfamiliar constellations are now familiar to you, patterns you have learned and internalized, and you locate the beacon and the bridge without effort. The night sky here is your night sky now, and the landscape around you is your landscape, and the community you are part of is not a distant outpost of Earth civilization, but simply civilization. The continuation of human presence under different stars. The connection to Earth remains real, but it is increasingly historical, a point of origin rather than a constant reference. You think about the generations that will follow, the people who will be born here and live their entire lives here and die here without ever seeing Earth or any other world. And for them, this place will not be a new world or an alien planet, but simply the world, the only world that matters in their immediate experience. They will know Earth through history and images, much as people on Earth know ancient homelands their ancestors left generations ago, and the emotional connection will be real but abstract, meaningful but not defining. The settlement has reached a threshold where it can sustain itself without ongoing support from Earth. And while new arrivals and new information are welcome, they are no longer necessary for survival. The population is large enough for genetic diversity. The agriculture produces surplus. The manufacturing capabilities can maintain and replace essential equipment. And the knowledge base includes skills and expertise across all necessary domains. The settlement has transitioned from colony to community, from outpost to home. And the distinction is not marked by any single event, but by the gradual accumulation of stability and self-sufficiency. You reach your quarters and pause at the entrance, looking back at the settlement. And the lights scattered across the structures create a small constellation of human presence on the surface, of a world that orbits a star 30 light-years from Earth. The journey that brought you here is complete, not because you have arrived at a destination, but because this is no longer a destination. It is simply where you live, where you work, where you are part of something larger than yourself. The universe remains vast and filled with unknowable distances, and countless other worlds. But this world is yours, and the sky above it is yours, and the community here is yours, and that is enough. The door closes behind you, and the sounds of the settlement fade, and the quiet of your own space settles around you. And outside, the stars continue their slow rotation across the night sky, indifferent and eternal, marking time in a universe that is home to countless worlds, and perhaps countless other beings asking the same questions, building the same fragile structures of meaning and connection against the vast indifference of space. Humanity has taken one small step outward, establishing a presence on one world among billions, and the endeavor continues, uncertain and determined, reaching toward a future that is unwritten and unfolding one generation at a time.